introduction to delegates in .NET. So let me quickly illustrate this point with an active example so that you can feel at home. Let us fire new project, this time a Windows Form application, and name it as Delegates Demo. Click OK to create this project. Now before I start telling you about delegates, you should know or you should already been familiar with the old function pointers in C applications. Function pointers are nothing but they are sophisticated layers over the function itself. So instead of calling the function itself, you can call it through the pointers also. So function pointers once back in .NET is in the form of delegates. Let us quickly write a function. Let us first get a small because I'll be doing some stuff like, let me have two text boxes first. Text box 1, text box 2, no fascination, nothing. We have a button. It will be adding up numbers. So let me name it as add and appropriately have it named as btn add. That's fine. And these are the two text boxes with the name text box 1 and text box 2. So now what I'll be doing is that let us quickly write a method add which will be responsible for doing this task. So let us quickly create a class for it. Now class numerics, and let me have a simple integer returning method add which accepts nothing but two numbers a and integer b and returns the summation of a and b. That's it. Fine. And for a future reference, because I'm going to tell you a bit about delegates more, so let me have another such function which is multiply. That's fine. For multiply, it will be again be returning the multiplication result of a and b. So with these two functions, let us proceed with our example. Now let me have two buttons then, one for add, another for multiply. That's fine. So click on properties. This is for multiplication and name it appropriately btn. That's fine. So having two buttons add and multiply, so the easiest way to invoke them is very simple. First create an object instance of this numerics class and then invoke the proper method of it. So it's very simple. Numerics n equals new numerics and then n dot add. Now till now I haven't taught anything special about what you learn, I mean what you're going to learn, but you will very soon see the purpose of adding up these two methods. So n dot add will be adding up two numbers and these numbers will be taken from these two text boxes. So quickly have two integers, integer x and integer y. X will be taken from the text box, so int dot parse text box 1 dot text, and the y will be parsed from the text box 2. That's fine, and that's it. That's good. And finally we are going to invoke this add method, so I can pass in this x and y. So x will be going into a local input variable, input parameter of this numerics function, and y will be going to b, and thereby adding these two things is just pretty much a basics one, but soon you'll understand. Like it will be returning you one result, so I'll just type in res for result, and definitely because this is Windows application I can fire up messagebox.show. Now I'm taking help of this Windows application because it is easier to illustrate with the help of the buttons and all, but the concept remains same all across .NET, whether it is web application or Windows application or console application. Any sort of application will be having this concept. that is delegates, because this is a core concept of .NET. So the res is a result, and definitely has to stringize this to see the result. And similar the kind of code will be there for the multiplication as well. So 7 plus 9 gives 16, that's fine. Let me quickly write the same stuff for this multiplication, just that the function name and the operations will be different. That's it. All fine, just replace this by mul, and we are done. Very simple. 7 and 5 adding up will be giving us 12, and multiplication will be giving us 35, which is fine. Now this example is perfect, and for the things like we are invoking functions. That is how we have been invoking functions. Now in case of static functions, we normally don't create the class instance, but we directly call the function name on the class itself rather than creating a object on it. These things you are already aware of. But the thing that you should know is about one thing you can point out. If someone is telling you that, hey, if I am in this line, which function is going to be called? At end dot, you can clearly say that it is add, because we have mentioned add over here. Or if someone is telling that I am here, which function is going to be called on n, you can clearly say that it is going to be mapped with mul. This is known as static polymorphism, not the dynamic polymorphism. Static, it's known as static binding. It is known as static binding. That is function name. You just looking at the function name while you are coding, you can say that mul means you are calling here. My call, my control will be coming right here once it encounters this line. Isn't that so? But delegates really achieve something beyond that. It is about runtime polymorphism or dynamic binding. You can see like what it is really so. Like when the function call is made, no one can tell with which function this is actually going to be bound with. Let us say we want a functionality that either of add or multiplication will be called. I don't know which one will be called. Let us think such a scenario. Toolbox, yes. Like, let me have a button out here, which is something I don't know which method is going to be called. So, like, cross this one, the time being. I'm putting all interrogation sign because I really don't know on the click of this button either of add or mul will be called. Either add may be called or mul may be called. So if you really have to program in this way, what you can do is yet another simple thing. You know that we can use some random function in .NET. Like it can be randomly choosing either of two values. If like head or tail kind of situation. If it is head, I'll be calling add, and if it is tail, I'll be calling multiplication method. So this head or tail kind of situation has to be encountered over here. Let me quickly do this kind of head and tail situation, or like randomizing the selection, whether it is add or multiplication. It's very simple to do this. For that, we must have a random function. Random r equals new random, and then let me have an integer like integer x, that is fine, equals r dot next, and I will choose values between say 1 and the maximum value to be 3. Now why I am writing 3? Because if I choose 3, it will be giving 1 less than 3. Please understand, this is something that I have noted. So if I write 1 and 2, it will be giving random number in the range of 1 and 1 itself. So no randomizing at all. So if I write 1 and 3, it will be giving me numbers between 1 to 1 less than 3, that is 2. So if I write this statement, I will be having this x as either 1 or 2. So either it can be 1 or it can be 2. So this is the minimum value and this is the maximum value. 1 less than this maximum value will be chosen. So now depending upon this x, so if this x equals 1, I'll be doing addition. I'll be doing addition. That means, okay, let me have this rest part and all these things copied up, because I need all these things up there. Just that I won't be writing this one because this will be taken decisively. Just rest. So we have got 2 variables, and we are definitely having this numerics object, 2 variables, and the inputs are taken into x and y. Then the result will be captured in res, but we don't know whether of add or multiply is going to be called. That is totally a random decision. And if it is x, then what we can do is that x response will be addition of, I'm sorry, it's because I'm already using this x variable, so I should just name it something else. So let us name it as r for random. That is fine. So if r equals 1, then what I'm going to do is I am actually going to write this, going to invoke n dot add and pass in this x and y. Else this res will be n dot multiplication of x and y. Why this red jagged error message? Did I do anything that is mistake? Cannot implicitly convert. I'm sorry. I'm actually sorry. It should be named as rand, because this is a random function. This is the object of random class. Then on this I should be invoking this rand dot next 1 to 3. So we are creating a random function. A random object. This is we are initializing an instance of this random class, and then calling the next method on it and passing in minimum and the maximum plus 1. So we have to subtract 1 internally, because I want the value to be between 1 and 2. So I have supplied 1 more than that, 3. Otherwise the value will be even dripped by 1. I hope you understand this. So if r is 1, then I am going to do a addition, and if it is multiplication, if it is not 1, that is, it should be 2, I am going to do a multiplication. Finally, I can output message box dot show to print the response. I know I am really creating a lot of groundwork to teach you delegates, because I believe that most of the people really don't have that amount of initial basic knowledge. So for that I am working hard so that you can really understand the use of delegates all of a sudden. Okay, if we do this, then something new can be done. So till now I haven't used delegates at all. I haven't taught you delegates at all. It's very simple. It's just that if it is 7 and 8, so addition result will be 15 and the multiplication result will be 56. But this will be choosing randomly out of add or multiplication. It is 15, that means this time it has yielded 1 as a random result, so 15 is chosen. Now this time it is 56, again 15, again 56. You see how beautifully 56. Now 2 times multiplication was chosen. So we can actually go on doing this stuff. I can see this is totally random. you really don't know, like 3 to 4 times 15 can come, you cannot really tell that why it is getting more biased over to this multiplication portion, to the addition portion, but multiplication result will also be shown. This is what is the nature of this multiplication, this nature of this randomness using this random class in .NET. That is fine. But till now, if someone is telling you that, hey, if I am here, to which method this is binding to, you can definitely argue, because this, you can see in your eyes that it is n.add. That means definitely it is going to this add method. And if it is n.mul, it is definitely going to this mul method. But I am going to create another version of it using delegates now. Just another version, but now using delegates. Here you really will not be able to tell from the program itself, from the compile, from the while you are in the program, that you cannot tell that to which this is ultimately going to bound with. So let me write the same stuff, or at least have this much, that is fine. Up to this much is great. Now I have told you, did I not, that delegates are function pointers. Now what I am going to do is that I am going to create a signature, a function signature that can hold either of this add or mul function. You can think delegates are a kind of function variables also. Like we store data in variables. Now using delegates, delegate variables actually store function names. Very simple. For that you must declare the appropriate delegate type. Don't worry what I am telling you right now. Just think about how is exactly this addition and multiplication is defined. They are having two input types, both are integers, and returning an integer. So let us create a delegate, and it should be created outside any class, because it itself is a kind of class. So let me write in this way: delegate. This is del for the name of this delegate. What it does is that it actually returns an integer and takes two integers, integer a and integer b. Got my point? Delegate int del is the name of my delegate. Now this is totally my user defined name, del int a int b. That means both add and mul is of type del. Do you get the point? Both add and mul is of type del. So what we can do here is very interesting thing. We should first create del d, that's it, and then what we can do is that if r equals 1, then I'll be storing here d equals add add. Sorry for that. Else d equals mul. You see how beautiful is this thing. Add is being pushed into d and mul is being pushed into d, but we actually can't do this directly. Very simple, because add and multiplication belong to this numerics object. So we must do in this way. Very simple. We must write that n, we have declared this n, so it is n of add and this is n of mul. You get the point? Very simple. Like I haven't I just did tell you that using delegates you can actually capture the function names. So just think about delegates are a very sophisticated way of holding functions itself. So d equals n dot add. Now here d equals n dot mul. Now we will directly be invoking this D. I'll write D like this. We have captured the data pieces from the text boxes into X and Y. So X comma Y. Now dear student, can you really tell me that if this is occurring, let me complete this first. Coming to this response, and again this message box dot show this response telling you, just wait a minute. Now can you please tell me that if you are in this line, or if I am right now, I will tell you, if I ask you that if you are in this line, to which function you are going to be mapped to, you cannot tell. The reason is that only is determined in the runtime, because if in the runtime D is being assigned a value of add, then it will be executing the addition, or if in the runtime D was assigned a value of mul, if D is assigned to mul function, then this D will be dxy will be actually invoking this multiplication. That means we really don't know to which method D is going to be pointed to. This is known as runtime polymorphism or dynamic binding. So functions can be statically binded or it can be dynamically binded. Delegates are dynamically binded. This is just one such use of delegates for the beginners. There are indeed a lot of usage of delegates that are really coming up. I think you have got the point. First let me just run this, execute this, and show that this really works. It is 8 this time. That means the addition was done, because 1 plus 7 is 8, and once again this 7 this time, that means multiplication is done, because 1 to 7 is 7, and this is once again the addition, once again additions. In this way you are really randomizing the stuff that shows that you can use delegates to attain runtime polymorphism or late binding, sometimes also known as late binding. Please comment. I think I have gone through some length to teach the basic usage of delegates and how do you really use delegates. Just for one more thing, I have used some shortcuts for you. The real way of writing this is not exactly this, because you can think about delegates are an object oriented wrapper over function, object oriented wrapper counterpart of function pointer. Just don't worry about all this terminology. Like instead of writing this, like as you know that for every such object we create, we use a new statement, don't we? Like if it is numeric n, we use a new statement. For this too, we could have invoked a new statement just like this, new delegate, and then passing over to this add. Here also new delegate, then passing over to this mul. And true way of invoking this D is writing D dot invoke. This is the complete way. But don't worry, if you omit that invoke, if you omit all of these new del statements, they are internally being done for you. So this is a shortcut which is available from C# 2.0 onwards, but prior to that it was not available. You have to write the entire one, especially in kind of threading situation that I have used. I used to write the entire of thread start delegate. Okay, that is fine. Dear viewers, please comment on my video. And this is Shudipto Kumar Mukherjee. If any question, please post it on the YouTube. Thank you very much for watching this video.